One of the big problems of them traditionally is they need quite a lot of diameter. So if you have something of similar torque, it might be that the diameter is another 50 or 60% bigger. And that actually causes a big problem.
The ground beneath the auto industry just cracked. Mercedes has unveiled the YASA Flux engine, a machine so advanced, so brutally efficient, that it threatens to rewrite everything we thought we knew about speed, power, and future mobility. This isn't just another engine. It's a seismic shift, a technological earthquake leaving rivals scrambling and investors gasping. The question isn't if the industry will change, it's how quickly it can survive the shockwave.
A new topology of axial motor called the YASA machine, yokeless and segmented armature, where the stator is broken into a number of pieces. And through a number of magnetic and thermal tricks, we were able to squeeze the diameter so they're actually pretty comparable with radial machines, making them much easier to package in vehicles.
The journey towards the YASA Flux engine began in 2009, within the walls of a modest laboratory at Oxford University. It was there that Tim Woolmer, a doctoral candidate, questioned the conventional approach to electric motor design. Woolmer had become frustrated with the limitations of existing electric motors, particularly the radial flux machines that were dominant at the time. These traditional motors were large, heavy, and inefficient, using iron cores stuffed with copper windings and laminated steel, components that contributed to unnecessary weight and waste. Woolmer saw an opportunity to challenge this approach by asking a fundamental question: why should magnetic fields travel the long way around a cylindrical motor when they could cut straight across a disc? After a week of intensive work, Woolmer sketched the concept of what would become the YASA Flux motor. This design featured a yokeless and segmented armature, a stator composed of individual slices bonded by epoxy, rather than relying on a bulky steel yoke. It was a simple yet radical idea that addressed the inefficiencies inherent in traditional motor designs. What started as a theoretical concept soon took shape with the help of a small startup grant of $1.4 million, enabling the creation of a hand-wound prototype. The first prototype was a disc-shaped motor weighing just 12 kilograms. Despite its relatively modest size, it was capable of producing 50 kilometers of continuous power, a remarkable feat that defied expectations. When the motor was tested by a group of visitors who had expected a device no more powerful than a typical desktop fan, they were stunned by its performance. This early success sparked interest from local angel investors, and by 2013, the company, now known as YASA Limited, had expanded its operations into a converted chicken shed in Yanton. Here, engineers developed a second-generation unit, this time operating at 750 volts, and successfully tested it in a radical SR8 car. The motor was able to run for 11 hours straight at the Bedford Autodrome without experiencing thermal rollback, a significant achievement in the world of electric motors. The impressive telemetry data from these tests caught the attention of major players in the automotive industry, including Ferrari. In 2019, YASA's disc-shaped motor was incorporated into Ferrari's SF90 Stradale hybrid, marking a major milestone in the motor's journey. Ferrari was so impressed by the performance of the YASA Flux engine that it placed an order for 3,000 units per year. Other luxury manufacturers, including Lamborghini and Lotus, also expressed interest, with Lamborghini even considering the motor for its Revelto supercar. However, scaling up production to meet the increasing demand required more than just technical prowess. The process also demanded advanced manufacturing capabilities and the secure supply of materials, including rare earth metals. These challenges led YASA to seek a solution that would allow them to meet the needs of the automotive industry while maintaining their commitment to innovation. The breakthrough came on July 1, 2021, when Mercedes-Benz announced that it had fully acquired YASA. This acquisition positioned YASA's Flux engine as a key component for future AMG products. Mercedes' acquisition provided the financial backing and infrastructure necessary to automate production and ensure a reliable supply chain. Despite concerns that corporate rules might stifle the creativity that had defined YASA's early success, Mercedes allowed Woolmer's team to continue designing the assembly lines, incorporating cutting-edge technologies such as laser brazing heads and AI-powered vision systems for quality control. 2 production plants were established, one in Yanton for pilot batches, and another in Berlin, Marienfelder, for high-volume production. The plants were purpose-built with a focus on efficiency, automation, and scalability. In May 2025, the revamped Yanton plant officially began operations, producing the first batch of YASA Flux engines destined for AMG vehicles. Chairman Jörg Mesa of Mercedes-Benz announced that the plant would have an initial production capacity of 25,000 units per year, with the potential to scale up production to meet demand. This marked the beginning of a new era for electric performance, with the YASA Flux engine poised to play a central role in the future of high-performance electric vehicles. The YASA Flux engine's unique design is a key factor behind its success. Unlike traditional radial flux motors, which rely on a bulky iron core and a yoke to guide magnetic flux, the YASA motor uses a flat, disc-shaped rotor that allows magnetic fields to cut straight across the motor. This design significantly reduces the amount of iron needed, eliminating the yoke entirely and cutting down on energy losses caused by eddy currents. The result is a more efficient motor with a higher torque density, allowing it to deliver more power without increasing size or weight. According to a report from May 2025, the YASA Flux motor weighs just 25 kilograms, but can deliver 4 times the continuous power density of typical permanent magnet motors. In addition to its impressive power density, the YASA Flux engine also excels in thermal management. Unlike traditional motors, which struggle to dissipate heat, the YASA motor uses oil to cool the copper windings through microchannels, preventing thermal buildup and ensuring sustained performance under heavy loads. This innovation allows the motor to maintain an output of 200 kilowatt for up to 20 minutes without derating, meaning it can deliver consistent power without overheating. This ability to cool the motor at the root, rather than relying on external cooling systems, makes it more efficient and reduces the overall weight of the vehicle. Mercedes-Benz has taken full advantage of the YASA Flux engine's compact design, integrating it into their vehicles in ways that were previously impossible with traditional motors. For example, the motor can be placed between the crankshaft and the gearbox, or even beneath the rear seat, creating more space for passengers and cargo. Additionally, the smaller size of the motor allows for more flexible vehicle layouts, enabling Mercedes to design cars that are lighter, more aerodynamic, and more efficient. In one test vehicle, the integration of the YASA motor allowed Mercedes to lower the battery by 18 centimeters and reduce the car's weight by 200 kilograms. This weight reduction improved the car's performance, making it quicker in handling tests, including a slalom course. The benefits of the YASA Flux engine are not limited to performance alone. The motor's design also has a significant impact on energy efficiency by reducing the amount of waste energy generated during operation and improving cooling efficiency. The YASA Flux engine has helped Mercedes achieve higher overall energy efficiency for its vehicles. With a peak efficiency of 96% and an average efficiency of 93% under WLTP testing conditions, the YASA motor outperforms many traditional radial flux motors in terms of energy consumption. This higher efficiency translates to smaller battery packs, lower energy costs, and longer driving ranges, making electric vehicles powered by the YASA Flux engine more practical for everyday use. In addition to the technical and performance benefits, the YASA Flux engine also plays a key role in Mercedes's broader sustainability strategy. The motor's compact and efficient design reduces the need for rare earth metals, with the content of dysprosium, the rare earth metal most commonly used in electric motor magnets, reduced by 60% compared to previous designs. This reduction in rare earth metal usage not only makes the motor more sustainable, but also helps mitigate the environmental impact associated with mining these materials. Ultimately, the YASA Flux engine represents a paradigm shift in electric vehicle design and performance. With its unique combination of efficiency, power, and compactness, it has the potential to redefine the future of electric cars. Mercedes-Benz's commitment to scaling up production and investing in advanced manufacturing technologies ensures that the YASA Flux engine will play a central role in the company's electric future. As the motor moves from prototype to production, it is clear that this innovative technology will be a driving force in shaping the next generation of high-performance electric vehicles. The YASA Flux engine's innovation is rooted in its groundbreaking design, which sets it apart from traditional electric motors. To understand the full impact of this new technology, it is crucial to explore the mechanics behind the YASA motor's development and its numerous advantages in terms of power, efficiency, and design. By challenging the traditional radial flux motor, YASA has not only improved the performance of electric vehicles, but has also revolutionized how motors are designed, manufactured, and integrated into electric vehicle platforms. The most significant departure from traditional motor designs lies in the core architecture of the YASA Flux motor. Most electric vehicles today rely on radial flux motors, which are shaped like a cylinder and operate with magnets rotating around a large iron core. This design has been in use for decades, and while it's reliable, it's also heavy, inefficient, and generally takes up a lot of space. In contrast, the YASA Flux motor adopts a much more compact, flat disc shape that allows for a complete redesign of the motor's internals. This single change addresses multiple issues that affect conventional motors, such as size, weight, energy efficiency, and cooling. The key to the YASA motor's performance lies in its ability to conduct magnetic flux in a completely different manner. In a radial flux motor, magnetic field lines travel the long way around the cylindrical stator, often encountering unnecessary resistance as they do. In the YASA design, however, these magnetic lines travel directly across the disc, cutting through the motor's stator more efficiently. This clever alteration not only eliminates the need for a bulky steel yoke, one of the heavy components in a conventional motor, but also reduces energy loss caused by eddy currents. By streamlining the flow of magnetic fields across the motor, the YASA Flux engine halves the amount of iron needed in the construction, leading to a significant reduction in weight without sacrificing power output. With less iron and no bulky yoke, the YASA motor is much lighter and more efficient than traditional motors, offering twice the torque density. Torque density refers to the amount of torque a motor can generate relative to its weight. This means that for its size, the YASA motor can generate a considerable amount of power, making it highly effective in delivering high-performance output while keeping vehicle weight down. According to industry reports, the production version of the YASA Flux engine, which weighs only 25 kilograms, can deliver continuous power at a rate 4 times higher than typical permanent magnet motors. This impressive power-to-weight ratio is one of the key reasons why the YASA Flux engine is being adopted in high-performance electric vehicles, including those from Mercedes-Benz. While a reduction in weight and an increase in torque are essential, a motor must also be able to handle high power levels without overheating. This is where YASA's innovative cooling system plays a vital role. Traditional electric motors often struggle with heat dissipation, which can lead to performance degradation or thermal failure when subjected to continuous use or heavy loads. In contrast, YASA tackles the issue of heat management directly within the motor's structure. The motor uses oil, which flows through microchannels in the copper windings, to efficiently absorb and carry away the heat generated during operation. This approach eliminates the need for bulky external cooling systems that are common in other electric motors, helping to maintain efficiency while reducing vehicle weight. As a result of this advanced cooling system, the YASA Flux motor can sustain 200 km output for up to 20 minutes without experiencing thermal derating, a phenomenon where the motor's performance is reduced to prevent overheating. This is a major breakthrough, as most conventional motors would begin to lose power or shut down after sustained high loads. The ability to maintain high power output over extended periods without compromising performance is particularly beneficial for performance-oriented electric vehicles, where maintaining consistent power delivery is critical. The impact of this cooling and design innovation extends beyond just the motor's capabilities. The compact and efficient design of the YASA Flux motor opens up new possibilities for vehicle architecture. Traditional electric motors are typically large and can be challenging to integrate into the vehicle without compromising passenger space or vehicle dynamics. However, the smaller, flat-disc design of the YASA motor allows it to be placed in unconventional locations within the vehicle. Mercedes-Benz has already demonstrated the versatility of the YASA motor by integrating it into various parts of their vehicle platforms. The motor can be positioned between the crankshaft and the gearbox, under the rear seat, or even within a wheel hub, configurations that are not possible with conventional motors. These flexible installation options enable manufacturers to design vehicles with more space for passengers and cargo, improved aerodynamics, and a lower overall weight. The YASA Flux motor's compact size also allows for more efficient energy use. In traditional designs, the size of the motor often dictates the size of the battery and other components, leading to larger, heavier vehicles that require more energy to operate. However, by reducing the motor's weight and size while maintaining power output, YASA enables vehicle manufacturers to design electric cars that require smaller batteries. This is particularly important for reducing overall vehicle weight and improving range, as a smaller, lighter battery can store energy more efficiently. In some test vehicles, the integration of the YASA motor has resulted in the reduction of the battery pack size, leading to lower vehicle weight and improved energy efficiency. To demonstrate the real-world performance benefits of the YASA Flux motor, Mercedes-Benz conducted a series of tests on a prototype vehicle equipped with the new motor. In one notable test, the vehicle saw a reduction in weight by 200 kilograms, thanks to the smaller YASA motor and the repositioning of the battery. This reduction in weight directly contributed to the vehicle's performance improvements. In slalom tests, the vehicle's handling and agility were significantly enhanced, allowing it to navigate tight turns more easily and with greater precision than previous models. Additionally, the YASA motor's design helps to improve driving dynamics by reducing rotational inertia. In traditional electric motors, the rotor, the part of the motor that spins, can create gyroscopic forces that resist changes in the vehicle's direction. This is particularly noticeable during cornering, where a motor with high rotational inertia can make a car feel less responsive. The YASA Flux motor, however, has almost no rotational inertia, meaning that when the driver turns the wheel, the car responds much more quickly. This improvement in handling, combined with the motor's ability to maintain stable performance at high speeds, contributes to a more enjoyable and responsive driving experience. The YASA Flux motor's technical achievements are not just about performance, they are also deeply tied to its sustainability. The motor's design and manufacturing processes have been optimized to minimize environmental impact. For example, the use of rare earth metals, materials that are often sourced through environmentally harmful mining practices, has been significantly reduced in the YASA motor. Specifically, the content of dysprosium, a rare earth metal commonly used in electric motor magnets, has been cut by 60% compared to earlier designs. This reduction in rare earth metal usage helps to mitigate the environmental consequences of mining and makes the motor more sustainable in the long run. Furthermore, the YASA motor is built with recycling in mind. Its segmented core design makes it easier to dismantle at the end of its life cycle, which helps improve the motor's overall recyclability. This is an important feature, as the automotive industry faces growing pressure to develop products that are more sustainable and easier to recycle. The EU's stricter regulations on waste management and recycling, set to come into effect after 2030, will only increase the demand for products like the YASA Flux motor that are easier to disassemble and recycle. In addition to these environmental benefits, the YASA Flux motor also provides significant improvements in energy efficiency. According to testing results, the motor achieves an impressive peak efficiency of 96% and an average efficiency of 93% under WLTP testing conditions. This high level of efficiency means that electric vehicles equipped with the YASA motor can travel longer distances on a single charge, reducing the need for frequent recharging and making EVs more practical for everyday use. In fact, the improved efficiency of the YASA Flux motor has been cited as a key factor in reducing the size of the battery packs used in vehicles, further reducing weight and increasing energy density. The success of the YASA Flux engine marks a pivotal moment in the development of electric vehicle technology. By rethinking the design of electric motors, YASA has created a product that not only delivers higher performance and greater efficiency, but also reduces environmental impact and improves vehicle dynamics. The YASA Flux motor's ability to combine power, efficiency, and sustainability in a single compact design has paved the way for the next generation of high-performance electric vehicles. With major automakers like Mercedes-Benz already adopting the technology, it is clear that the YASA Flux engine is set to become a cornerstone of the electric vehicle industry for years to come. The production and scalability of the YASA Flux engine represent a crucial step forward in the advancement of electric vehicle technology. While the motor's design and performance benefits are impressive, its successful integration into the automotive industry required not only a groundbreaking approach to engineering, but also a new mindset in manufacturing. Mercedes-Benz's full acquisition of YASA in 2021 was a strategic move that paved the way for the motor's mass production. This acquisition allowed YASA to scale up operations and meet the demands of major automakers, while still preserving the creativity and innovation that had made the motor so unique in the first place. One of the key challenges faced by YASA was scaling up the production of their revolutionary motor without compromising on quality or innovation. Traditional manufacturing methods would not suffice to meet the high standards of performance and efficiency required for automotive applications. As a result, Mercedes-Benz worked closely with YASA to design state-of-the-art manufacturing processes that would enable the production of thousands of motors each year, while maintaining the motor's high performance and sustainability standards. The first step in the process was to build 2 dedicated production plants. One of these plants, located in Yanton, was intended for pilot batches and small-scale production. The other, located in Berlin-Marienfelder, would be responsible for high-volume production, where the motor would be mass-produced for use in Mercedes-Benz vehicles. These plants were equipped with the latest technology and automation systems, allowing for highly efficient production processes that could be scaled up rapidly as demand increased. In the Yanton plant, a focus on precision and efficiency was paramount. Mercedes-Benz and YASA invested heavily in advanced robotic systems, AI-powered vision systems, and laser brazing techniques to ensure that each motor was built to the highest standards. The production process was designed to minimize waste, reduce scrap rates, and improve the overall quality of the motors. One of the most important innovations in the manufacturing process was the use of robots to lay copper ribbon into pre-molded slots in the motor's stator. This method not only improved the accuracy of the stator assembly, but also increased production speed, allowing for the efficient manufacturing of large quantities of motors. The Berlin-Marienfelder plant was built to handle high-volume production, with the ability to produce up to 25,000 motors per year in its initial phase. The facility was designed with scalability in mind, meaning that as demand for the YASA Flux motor grew, the plant could be expanded to meet those needs. Mercedes-Benz invested hundreds of millions of euros into the facility, equipping it with cutting-edge technology such as laser balancing systems and advanced coil production lines. The plant's production process was optimized for speed and efficiency, with a high level of automation reducing the need for human intervention in many parts of the assembly line. One of the key advantages of the YASA Flux motor's design is its modularity. The motor's compact size and efficient design allow it to be easily integrated into a variety of vehicle platforms, making it suitable for use in everything from luxury sedans to high-performance sports cars. Mercedes-Benz has made it clear that the YASA Flux engine will be a cornerstone of its future electric vehicle offerings, including its AMG line of performance cars. The motor's versatility means that it can be used in a wide range of vehicles, from sedans to SUVs, and can be tailored to meet the specific performance requirements of each model. The scalability of the production process has been a major factor in the motor's success. With the production capacity at the Yanton and Berlin Marienfelder plants, Mercedes-Benz is now able to produce the YASA Flux motor in large quantities, ensuring that it can be integrated into a wide range of electric vehicle models. The ability to produce tens of thousands of motors per year also means that Mercedes-Benz can offer its customers a more affordable electric vehicle option without sacrificing performance. As the demand for electric vehicles continues to rise, the scalability of the YASA Flux engine's production process will be crucial in meeting that demand. At the same time, the production process has been designed with sustainability in mind. One of the key challenges faced by the automotive industry is the environmental impact of manufacturing processes, particularly in the production of electric vehicle components. Mercedes-Benz and YASA have worked hard to ensure that the production of the YASA Flux motor is as environmentally friendly as possible. For example, the factory's use of renewable energy, including solar power, helps to reduce its carbon footprint and reliance on non-renewable resources. In addition, the use of advanced robotics and AI systems has helped to reduce waste and improve the efficiency of the manufacturing process. Another important aspect of sustainability in the production of the YASA Flux motor is the reduction in the use of rare earth metals. Traditional electric motors rely heavily on rare earth metals like neodymium and dysprosium, which are both expensive and environmentally damaging to extract. By reducing the content of these materials by 60% compared to earlier designs, YASA has made the motor more sustainable while also reducing its cost. This reduction in rare earth metal usage not only benefits the environment, but also helps to make electric vehicles more affordable for consumers. The YASA Flux engine's design is also well suited for the future of electric vehicle recycling. As electric vehicles become more common, the industry will need to develop effective ways to recycle the components that make up these vehicles, including the motors. The segmented core design of the YASA motor makes it easier to disassemble and recycle at the end of its life cycle. This is a significant advantage over traditional motors, which are often difficult to recycle due to their complex and bulky construction. As regulations around recycling and waste management become more stringent, the ease with which the YASA Flux motor can be disassembled and recycled will become increasingly important. Beyond its manufacturing and sustainability innovations, the YASA Flux motor's impact extends to the broader automotive ecosystem. As the motor becomes more widely adopted, it has the potential to drive innovation in other areas of vehicle design. For example, the smaller size of the YASA motor allows for more efficient use of space within the vehicle. In a Mercedes-Benz test vehicle, the integration of the YASA motor allowed the battery to be lowered by 18 centimeters, reducing the vehicle's overall weight by 200 kilograms. This weight reduction not only improves performance, but also increases energy efficiency, as lighter vehicles require less energy to operate. In addition, the compact design of the YASA motor opens up new possibilities for vehicle layouts. The motor can be placed in unconventional locations, such as between the crankshaft and the gearbox, or within the wheel hub, freeing up space for other components. This flexibility in design allows manufacturers to create more efficient, aerodynamic, and lightweight vehicles that are better suited to the needs of modern consumers. The ability to integrate the YASA motor into various parts of the vehicle architecture also helps to reduce the overall cost of production, making electric vehicles more affordable and accessible to a wider audience. One of the standout features of the YASA Flux engine is its extraordinary performance capabilities. Unlike traditional electric motors, which often rely on large, bulky designs that sacrifice power for size, the YASA Flux engine offers a much higher power-to-weight ratio. The motor's disc-shaped design, which eliminates unnecessary components such as the bulky steel yoke, has made it not only lighter, but also more efficient at producing power. With a weight of just 25 kilograms, the YASA Flux motor is able to deliver up to 4 times the continuous power density of typical permanent magnet motors. This enables the motor to provide powerful performance without compromising on vehicle weight. This increased power density is critical in the development of high-performance electric vehicles. The YASA Flux motor's ability to deliver up to 200 kilowatts of continuous output for extended periods of time without overheating is a significant breakthrough in motor technology. Traditional motors typically struggle with heat dissipation during prolonged high-output operation, causing them to slow down or shut off to prevent damage. However, the YASA Flux engine uses a unique oil cooling system, with oil flowing through microchannels in the motor's copper windings. This system draws heat away from the motor's components before it can build up, ensuring sustained high-power output without thermal derating. As a result, the YASA Flux engine can maintain consistent performance in high-stress situations, such as during track days or extended highway driving, without risking damage to the motor. This capability has profound implications for the performance of electric vehicles. In real-world tests, vehicles equipped with the YASA Flux motor have demonstrated improved handling and quicker response times, thanks to the motor's low rotational inertia. In traditional electric motors, the rotor, the part of the motor that spins, creates gyroscopic forces that resist changes in direction. This can make the vehicle feel less responsive during cornering or rapid steering maneuvers. However, the YASA Flux motor's design eliminates this issue, allowing for faster, more precise steering response. The result is a vehicle that feels more agile and stable, with enhanced handling characteristics that will appeal to performance enthusiasts and everyday drivers alike. In addition to performance improvements, the YASA Flux motor also offers significant efficiency gains. The motor's efficiency is a key factor in reducing the overall energy consumption of electric vehicles. With a peak efficiency of 96% and an average efficiency of 93% under the WLTP testing conditions, the YASA motor outperforms many conventional radial flux motors. This high level of efficiency means that vehicles equipped with the YASA Flux engine can travel longer distances on a single charge, reducing the need for frequent recharging and making electric vehicles more practical for daily use. The improved efficiency also has a direct impact on the size and weight of the battery pack, as smaller, lighter batteries can now store the same amount of energy while maintaining or even increasing driving range. The motor's high efficiency is also closely tied to its environmental benefits. One of the main challenges with traditional electric motors is the amount of waste energy generated during operation. The YASA Flux motor, with its streamlined design and reduced iron content, minimizes energy losses and helps to reduce the overall energy consumption of the vehicle. The improved thermal management system also ensures that the motor operates at optimal temperatures, further boosting its efficiency. This enhanced efficiency reduces the vehicle's overall carbon footprint, making it an even more attractive option for environmentally conscious consumers. Another important consideration when evaluating the YASA Flux engine is its long-term durability and reliability. Electric vehicle owners expect their vehicles to be reliable and capable of enduring long distances without significant wear or degradation. The YASA Flux motor has been designed with this in mind, and it has undergone extensive testing to ensure that it can perform reliably over time. The motor's components, including its ceramic bearings and sealed construction, are built to withstand the rigors of daily driving, high-speed runs, and extended use without significant wear. In fact, the YASA Flux motor has already been tested over 1.6 million kilometers across 4 continents, and no bearing failures or significant performance issues have been reported. This long-term reliability is one of the reasons why the YASA motor has been adopted by high-performance car manufacturers like Mercedes-Benz, Ferrari, and Lamborghini, all of whom demand motors that can handle extreme performance demands without compromising on reliability. The motor's long-term reliability is also enhanced by its ability to be serviced and maintained more easily than traditional motors. In the event that maintenance is required, the YASA Flux motor can be disassembled and serviced with minimal downtime. The motor's modular design makes it easy to replace individual components, such as bearings or the stator, without having to replace the entire motor. This ease of maintenance helps to reduce the cost of ownership for electric vehicle buyers and ensures that the motor will continue to perform at a high level for the life of the vehicle. Furthermore, the YASA Flux engine's design contributes to the overall sustainability of electric vehicles. As electric vehicle adoption grows, the need for recycling and sustainable manufacturing processes becomes more important. The YASA motor's segmented core design makes it easier to disassemble and recycle at the end of its life cycle. This feature is particularly important as the automotive industry faces increasing pressure to reduce waste and improve recycling rates for electric vehicle components. The ability to recycle the YASA Flux motor's components more easily will help to ensure that electric vehicles remain a sustainable choice for consumers in the long term. Mercedes-Benz has also focused on making the production process for the YASA Flux motor as sustainable as possible. The company's investment in renewable energy sources, such as solar power, for its manufacturing facilities, helps to reduce the environmental impact of production. Additionally, the use of advanced robotics and AI systems in the manufacturing process has improved efficiency and reduced waste, ensuring that the production of the YASA motor remains as environmentally friendly as possible. The production of the YASA Flux engine is just the beginning of what promises to be a revolution in the electric vehicle market. As the motor is integrated into more Mercedes-Benz models, the impact of the YASA Flux engine will continue to grow. The engine's high efficiency, performance, and sustainability features make it an ideal candidate for electric vehicles, and its ability to be scaled up for mass production will ensure that it can meet the demands of the global market. Moreover, the flexibility of the YASA Flux motor's design opens up new possibilities for future vehicle architectures, allowing manufacturers to create a wide range of electric vehicles, from compact city cars to high-performance sports cars, all powered by the same revolutionary motor. Looking further into the future, the YASA Flux motor's potential applications are vast. Mercedes-Benz has already made it clear that the motor will play a central role in the company's AMG performance brand, with plans for it to be used in a variety of high-performance electric vehicles. In addition to its use in road cars, the YASA Flux motor's lightweight, efficient design makes it a promising candidate for other applications, such as electric aircraft and marine propulsion. As electric technology continues to evolve, the YASA Flux motor's versatility and performance make it a strong contender in a variety of industries beyond automotive. The introduction of the YASA Flux motor into the market marks a significant milestone in the development of electric vehicles. By addressing key challenges in motor design, such as size, weight, efficiency, and power output, the YASA Flux motor has set a new standard for what electric motors can achieve. With its proven performance, reliability, and environmental benefits, the YASA Flux engine is poised to become a key player in the future of electric vehicles, paving the way for even more advanced and efficient technologies in the years to come. As manufacturers continue to adopt and scale production of the motor, the YASA Flux engine's impact on the electric vehicle market will only continue to grow, shaping the future of transportation for generations to come.